Okay, in this video I want to talk about finding the scalar equation of a plane, and to do that you basically use this formula down here on the bottom right, but first I want to talk about where this comes from. So here's my little cruddy picture, and in my picture, okay, so the little black box is going to represent a plane. I've got 2 points in the plane, x, y, z, and x naught, y naught, z naught. The idea is if I can find a vector that lies in the plane, and if I can also find a normal vector, which is in red, that's going to be enough to describe the plane. So assuming my normal vector has components a, b, and c, well, we know how to find a vector between 2 points. You just subtract respective x, y, and z coordinates, or components, excuse me. And we know that if 2 vectors are perpendicular, or orthogonal, we know that their dot product is going to equal 0. Well, the first part's our vector in the plane. The second is going to be the components of our normal vector. If we multiply those, we get 0, but we know how to multiply them algebraically. You just multiply respective components and add them together using the dot product. So this is the idea. We basically need to find, so really what it says ultimately, it says you need to know a point in the plane, x naught, y naught, z naught, and it says you also need to know the components of a normal vector, and that'll be enough to get you what you need. So, okay, in this problem, I'm going to find the equation of a plane that goes through the points 3, negative 1, 2, 8, 2, 4, and negative 1, negative 2, negative 3. Okay, so it doesn't really matter how we label them. Maybe I'll call this one P, this one Q, and this one R. These all lie in a plane, so I'm going to find a vector between PQ and also PR. Again, it doesn't really matter which ones you do. So if we subtract respective components, we would get, okay, so from P to Q, we would get 8 plus 1, 2 plus 2, 4 plus 3. Remember, we subtract 8 minus negative 1, 2 minus negative 2, 4 minus negative 3. And P to R, we would get 3 plus 1, negative 1 plus 2, and 2 plus 3. So if we simplify, our vectors are going to be 9, 4, and 7. And the components of our other vector will be 4, 1, and 5. Well, why am I finding 2 vectors in the plane when we said all we need is 1 vector in the plane? That's going to be enough. Well, remember, if we can find 2 vectors in the plane, we know that their cross product is going to be perpendicular. So the cross product will create a normal vector. So here we're going to use the cross product of the vector PQ and PR, and this is going to give us the normal vector that we want. Okay. So at this point I'm going to have to compute the cross product. All we need is 1 point in the plane to use the formula, so I'm going to kind of keep my 8, my 2, and my 4 up here off to the side so I don't forget it. And now we're simply going to have to compute the cross product between these vectors here. So, okay, I'm going to try to go through this a little faster because if you need to see a cross product, I've definitely got a video devoted exclusively to it. So 9, 4, 7, 4, 1, 5 are the components of my vectors. Alright, so remember, it says we'll get I, and then we'll have to compute the determinant 4, 7, 1, 5 minus j, and if we get rid of j, we'll have 9, 7, and 4, 5. We'll have to compute the determinant of that. And then plus k, we have 9, 4, 4, and 1. Okay, so a little tedious here. I think I just said it and wrote it down wrong. So if we get rid of, here we go, 9, 4, 4, and 1. So let's see, 4 times 5 minus 1 times 7, that's 20 minus 7. That to me looks like 13i. We'll get 45 minus 28. 45 minus 28, I believe, is 17. J. And then for K, we'll get 9 times 1 minus 16. 9 minus 16 is going to give us a negative 7K. Okay, so going through that a little bit faster there. So again, this is now going to be our normal vector. So it says to find the scalar equation of the plane. We need the components of the normal vector, which I now have. And it says we simply take x minus a point. So it says we take the components a, x minus x sub 0, plus b, y minus y sub 0, plus c, z minus z sub 0, and set that equal to 0. Well, I've got my point left over. I kept one of the points. And again, this is our normal vector, so this is our a value, this is our b value, and this will be our c value. So it says the scalar equation of the plane is going to be 13 times x minus the x-coordinate, which is 8, plus b, well, let's go ahead and just write that as negative 17, y minus the y-coordinate, which is 2, plus c, which again is negative 7, z minus the z-coordinate, which is 4. And you could distribute this out. Sometimes people will distribute this out and move the constant to the left side, so knock yourself out if you want to do it. I'm not going to do that tedious arithmetic. But that would be one example of finding the scalar equation of the plane. So again, basically you need a point on the plane, and you need a vector that's normal or perpendicular to that plane. Depending on the information given, you know, again, like in this example, we actually had to find that normal vector by using the cross product. But, alright, I hope this video makes some sense. If you have any questions or comments, feel free to post them. Hopefully me or someone else can point you in the right direction.